Okay, take 3. I've recorded this thing 3 times. My mouth just isn't working. Blame it on the time of day. Okay, so we've talked about a probability distribution. We know that in any probability distribution, the sum of the probabilities must be 1. We also know that with the standard normal distribution curve, the area between the x-axis and the curve is also 1, which means the areas that we've been computing can be seen as probabilities. So for example, one of the examples that we did before was to find the area between 0 and a given z value. Let's say between 0 and 2. In that case, we know our general sketch had our 0 at the center, 2 of course to the right of that since it's positive, and we found the area accordingly using table E. In this particular case, this area ends up being 0.4772. Another way that we can think of that in terms of probabilities would be to say, what is the probability that z is between 0 and 2? In this case, that probability would be 0.4772, or you can write it as 47.72%. So it's not really changing anything in terms of the use or how we use table E and how we use this particular distribution. It's just a different way of looking at the same information. So some of your words or some of your problems will be written in word form. Others are going to be in kind of this inequality form. And there are various forms that we can take. For example, if we see the probability that z is greater than 1.5, then that tells me I'm going to draw a distribution. Mark 1.5 to the right of it. Greater than that would be in the tail. So it's just a matter of understanding what these symbols are telling you, because they're really just telling you in which direction to shade on your graph so that you can then appropriately use one of those methods we talked about earlier to find the area that you're asked for. So keep in mind that you can be given word form, or you could be given probability notation as we see here with those intervals. The last thing we need to talk about is kind of going in reverse order. For example, what if I told you the area that I wanted it to have, say between 0 and some z value? If I tell you the area, can you tell me which z value corresponds to it? So the way that those are going to look, first of all, they're going to be a little wordier, and you'll see why. It's just in the description that the words come out. Find a z value to the right of the mean. So that automatically tells me I'm looking for a positive value. If it's said to the left of the mean, then I know I'm looking for a value that's negative. Keep in mind, you'll have to remember to put the negative on your answer because it won't come out in the table, since the table only shows positive answers, but you'll have to remember to put that on there if it is a negative. In this case, I want to the right of the mean so that the area between 0 and z is 0.5, I can't read, 0.4591. I don't know why I wrote equals there, that's an is. Okay, so the area between 0 and z is that value. So in terms of what that looks like on our sketch, we're going to shade between 0 and z. There's my 0, here's my z, and I want the area between them to be 0.4591. Now, in terms of what that's going to mean on your table, I want to, on the table, find an area, and remember, these are the values that are areas. So I want to find the area 0.4591. 0.4591, right there. Trace it over to the left side, I see that starts with 1.7, and if I trace it up to the top, 0.04. So 1.74 becomes our z value. And as I said before, if you were dealing with something to the left of the mean, you'd have to remember to make that z value a negative. Here it's to the right of the mean, so it's a positive answer. So the question becomes, what if the probability or the area that we're given, like here, the 4591, what if that area isn't in the table? What if it's just close to a value in the table? When that happens, you want to find the value that is closest to. That may mean that it's below, it may mean it's above, but you find the one that it is closest to. If the probability that you're given, or the area that you're given, lies exactly between two values, like it is the midpoint of two values on the table E, then you find the larger z-value. So if it's not an exact value, find the value of z that has the closest area. If the closest area is exactly halfway between two values in the table, use the larger z-value. An example of where that's going to occur. Let's say I want to find the z-value to the right of the mean, so no, let's do a left of the mean this time. Find the z-value to the left of the mean so that the area between 0 and z is 0.45. Okay, so in this case, sketch it. Z is to the left of the mean, so now I've got a z on the left side. The area between 0 and z is shaded, and I know that area to be 0.45. Okay, so I'm in the table then looking for an area of 0.45. Now, when you go to look at your areas on your table, you'll find, sorry for the glare, you'll find that there are two of them. They're both equally close. Here we're about 5 10,000ths below, and there we're 5 10,000ths above. But it's 0.45 lies halfway between these two. So because it lies halfway in between them, I want to use the larger one. If it were a matter of it's closer to this one or that one, then I'd use whichever one it's closest to. So in this case, tracing it back, we see 1.65. In this case, the 1.65 lies to the left of the mean, which makes it a negative 1.65. One of the more common mistakes that we see is students forgetting to include the negative when it's a value to the left of the mean, because it's not something that the problem's going to force you to remember, you just have to remember to do it. Can't say that any more clearly than to make it that blunt and obvious, but you have to remember it on your own. All right, one more of that type. Find the z-value to the, let's do to the left of the mean. So that 73.24% lies to the right of it. Okay, so let's sketch our distribution here. Z-value to the left of the mean, so we have a z over here on the left side, and 73.24% to the right. Notice there is no upper boundary. We're not doing between z and some other value, so this is going to go all the way to the right. Now, from what we've previously discussed, we know that half of the values lie to the right of the mean, which means the area on this side is 0.5. Now, given the fact that the area to the right of z has to be 73.24%, if I take 73.24% in its decimal form, and subtract 0.5 from it, I end up with 0.2324, which is this area here. 0.2324. So if we look up this area, remember the areas in your table are between 0 and z, which is why that area was useful. If we look up this area, it's going to tell us our corresponding z value. So 2324 gives us a value of 0.62. There again, it's to the left of the mean, so we have to remember to make it negative. So the wording changes slightly, but the process is still the same. Each graph, once you have it sketched, should go back to one of those forms that we talked about previously. None of them should be in some form that you've never seen before. They all go back to the forms we talked about previously. With that in mind, there are some problems in the book that I think you should work through. I'll post those in class so that you know which ones they are. But ultimately, these aren't going to be the type of problem that you want to leap into without practice. You need to practice in order to get a firm footing in it, because this is going to become word problems in the next section. So knowing this material is crucial to being able to use it with the word problems themselves. And I know how we all feel about word problems. Me excluded, of course. But ultimately, practice, practice, practice. See you later.